Hi grade 12s, welcome back to my YouTube channel. Okay, what we're doing now is calculating the second derivative. This one is really easy, to be honest. It's exactly like how we were doing the first derivative, just now we're finding the derivative of that derivative. Okay, these are the notations for it. Usually we just write this, but if ever they ask this in the test or this over here, this is just saying we want the second derivative. Okay, you guys are quite familiar with this one for the first derivative. Okay, and you know that you have to simplify in here, then you find your derivative, and you're quite familiar with this one over here. This is basically dy dx. Okay, it's just written in this format. In the space of y, we write in f of x. Okay, don't stress too much about these formats. You're not going to see them as much in the test. This one you're going to see. Okay, so here's your example. Determine the second derivative. Okay, so I've got f of x is equal to 3x cubed. So the first derivative would be 9x squared. Okay, and the second derivative would be 18x. And that's it. That is literally it. Okay, here's a little longer one, nothing more complicated. So first derivative, negative 8x to the power of 3 plus 2 times 3 is 6x squared. Negative 5 times 2 is negative 10x. This one here is plus 10. And remember, if it's a constant, there's no derivative to it, right? Second derivative, negative 8 times 3, negative 24x squared, 2 times 6, and negative 10. And that's it. Okay, this one over here, don't forget we first have to rewrite this. Okay, I didn't leave enough space, but anyway, I'm going to write it over here. Okay, that makes it easier for us. Now to find the first derivative, this is going to be 12x to the negative 5 minus 4x to the negative 3. Okay, just subtract 1 from each of the powers to find the second derivative. This is going to be negative 60x to the negative 6 plus 12 x to the negative 4. And then you can rewrite this with positive indices. Okay, and that's it. That's finding the second derivative. Now, why is the second derivative so important? Okay, when we're going to be sketching graphs, you're going to have something, or we're going to talk a lot about something called the point of inflection. Okay, and then you're also going to be talking about concavity. Okay, so this is what I wrote for you here. Where our second derivative is greater than 0, so a positive number, okay, then it's concave up. If our second derivative is exactly equal to 0, that's our point of inflection. And where our second derivative is less than 0, that's concave down. Now, this here is what we're going to use when we are asked questions such as determine the point of inflection. So how you would do that is you take your second derivative. I'm going to pick this one here for an example, right? And then you equate it to 0 and you solve for x. That gives you your point of inflection. Okay, that one there. Or if we had this one over here, if this is our second derivative and I'm asking for the point of inflection of this graph, you're going to take this, equate it to 0, and so get your x value. That's your point of inflection. Okay. Now, when I say point of inflection, remember point has both an x coordinate and a y coordinate. So you find that x coordinate by doing exactly what I said. And to find the y coordinate, you take that x that you solved for and you sub it back into the original equation. And you're going to get your y coordinate. Okay? You're going to get questions where it says, for which values of x will the graph be concave up? Or for which values of x will the graph be concave down? I'm going to explain what concave up and concave down are in a second. I'm going to show you visually what it means as well. But what you would do if you had a question like that, you would take, let's use this one over here. So I have 18x. You're going to just say 18x greater than 0, solve. Or if the question said concave down, 18x less than 0, and then you solve for x, and that there would give you your answers. Now let's show you guys what concave up and concave down actually look like. Hold on. Right. Okay, when we say concave up and concave down, this is what it means. For this part over here, if you had to draw tangents around it, okay, so tangents are all the lines that can touch next to the curve. You would draw all of your tangents here above it, like this, all the way here. So there's tangents, 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 okay? When the tangents are all above it like this, it's called concave down. If the tangents that you're drawing to the curve are all below the curve, like this here would be concave up. So to recap, if it's like this way, anywhere in your graph, and if you see anything of this shape and you can draw the tangents above it, then it's concave down. If anywhere in your graph looks like this, it would be concave up. This point where it changes from concave down to concave up, okay, is known as the point of inflection. At this point, we know that the second derivative is equal to 0. That's what we know, okay? And it can be the other way around as well. I could have it look like this, all right? So do you see this one over here? We have it concave up until this point somewhere here. Then it changes and it becomes concave down. So this here is the point of inflection, concave up, concave down. Okay, that's what you need to know about concavity. Okay, let's continue. Right, so actual calculations where I was telling you for which values of x will it be concave up and concave down, right? I rewrote this here. For concave up, must be greater than 0. For concave down, less than 0. Okay, so what you need to do, find the second derivative and solve the inequality. Here's our example. I've given you f of x being x to the power of 3 minus 12x squared plus 36x. I'm asking you for the values of x where it's concave down. See how I found the first derivative and then the second derivative? We know concave down is where it's less than 0, so I took this whole thing. There it is, less than 0. Okay, took the 24 over, divided both sides by 6, and I got x being less than 4. And that's my answer. So anywhere on my graph where x is less than 4, my graph is going to be concave down. Let's try this next example. I've given you the equation. I need to find where it's concave up. So I need to find the second derivative. So first derivative. Okay, second derivative. Okay, we want it concave up, so okay, this here is going to be 12x minus 6. There we go. Basically, everywhere where x is greater than half, this particular graph over here is going to be concave up. Okay, this is very important to know. And that's it for second derivative and concavity.